Insertion sort works the way many people sort a hand of playing cards. It is an efficient algorithm for sorting a small number of elements. We start with an empty hand and the cards face down on the table. A few minutes into the game, and these are the cards we are holding in our left hand. At any time, the cards held in our left hand are sorted, and these cards were originally the top cards of the deck. Let's take one card from the deck and insert it into the correct position. To find the correct position of the card, we compare it with each of the cards already in our hand from right to left and place it there. Let's use this card analogy to see how insertion sort works on an array. The algorithm sorts the numbers in place using no extra space. We start at the second element, that's where pointer j begins. At the beginning of each iteration of the for loop, which is indexed by j, the subarray from index 0 to j-1 represents a sorted hand. Everything from index j onward is still unsorted, like the pile of cards left on the table. The element at index j represents the current card being inserted into the hand. This separation is our loop invariant. It holds true before each step. Next, we'll see how we maintain it using an example. Imagine we are in the middle of the insertion sort algorithm and pointer j is at index 3, pointing to the value 4. Everything to the left of j is already sorted. Our goal is to insert 4 into the correct position on the left side. We start by initializing a pointer I equal to j-1, so I points to 6. We make a copy of the value at index j and call it current card, as that's the value we're trying to insert. While I is greater than equal to 0 and the value at index I is greater than the current card, we shift that value 1 position to the right. So 6 gets shifted 1 position to the right and then we decrement I by 1. Since 5 is also greater than the current card, we shift 5 to position I plus 1 and decrement I by 1. Now 2 is not greater than the current card, so we exit the loop. At this point, we made room to insert the current card at the correct index of I plus 1, which is position 1, and we place it there. The core idea is to repeat this copy and shift logic for every element in the array starting from the second position, treating each one as a card we need to insert into the sorted segment on its left. Here is the code for insertion sort. Its time complexity is O of n square and space complexity is O of 1. But on partially sorted arrays, it can run in O of n time, and that's the beauty of this algorithm.